Welcome to this explainer. Today we're jumping right into some staggeringly precise, literally physics-defying numbers that make our universe capable of supporting life. We are taking an exhaustive, deep dive into what is arguably the most profound, unresolved mystery in modern cosmology, the observation that the fundamental physical constants of our universe seem to be set with a level of precision that is, quite frankly, terrifying. We're talking about numbers so precise that if they were off by even a fraction of a hair, reality itself would just collapse. We're going to look at the exact measurements that dictate existence, and we'll see why the scientific community is actively debating what these deeply unsettling numbers actually mean for our place in the cosmos.
To really feel the visceral shock of these numbers, we got to travel back to 1953. Picture this. Astrophysicist Fred Hoyle does something that had literally never been done in the history of science. He predicted an undiscovered physical property of nature, specifically a resonance energy level of the carbon-12 nucleus, simply from the fact that human beings exist. Hoyle reasoned, well, carbon-based life is here, so carbon must be efficiently produced inside stars. And for that to happen, carbon-12 needed a highly specific resonance energy. He asked nuclear physicists to go look for it, and, get this, they found it exactly where he predicted, at 7.6549 mega-electron volts. The conditions for our very synthesis were met with just razor-sharp precision.
Now, here's the kicker. Fred Hoyle was a committed atheist. I mean, this is the guy who coined the term Big Bang as a joke, right? He had absolutely no prior stake in the idea of a designed universe. Yet, this unbelievable precision deeply disturbed him. He famously admitted that a common-sense interpretation of the facts suggests a super-intellect has monkeyed with physics. That discovery totally shook his conviction that the universe was just the product of blind chance. And this visceral reaction from a highly skeptical physicist, that serves as our emotional anchor for everything we're about to discuss today. It is the deepest unresolved mystery in cosmology, and we are going to unpack exactly why.
Here is the structured path we'll take to unpack this immense topic. We'll start with the improbable physical constants, move into Penrose and extreme entropy, cover the 3 responses to fine-tuning, examine the anthropic firing squad, and finally, ask, why does anything exist?
Section 1. The improbable physical constants. Okay, let's dive into this. The constants we're about to explore aren't abstract, pie-in-the-sky philosophical concepts. They are undeniable, measured, physical facts that dictate the existence of stars, planets, and all chemistry. Take the strong nuclear force, for instance. It operates on a razor-thin 2% tolerance. If the strong nuclear force were just 2% stronger, 2 protons would bind together without neutrons, rapidly burning up all the hydrogen in the early universe. And no hydrogen means no water, no stars, and absolutely no life. Conversely, if it were 2% weaker, stars couldn't produce the heavy elements required for complex chemistry. So your very physical makeup, the atoms in your bones and your blood, depends entirely on this fundamental force being perfectly balanced on an impossibly tight tightrope. Now, when we compare the electromagnetic force to gravity, the ratio is a staggering 10 to the power of 36. That means gravity is unimaginably weaker than electromagnetism. And this incredibly vast ratio is exactly what allows stars to burn stably for billions of years. If this ratio were significantly different, say if gravity were just a bit stronger, stars would violently and instantly collapse into black holes, or they'd burn out in mere years, way before anything interesting could happen. Because it's perfectly tuned, stars last long enough for planets to accrete, cool down, and eventually allow life to evolve over deep time.
But honestly, those examples pale in comparison to a colossal magnitude known as the cosmological constant problem. Quantum field theory predicts an energy density of empty space that is wildly larger than what we actually observe out there. And this discrepancy isn't just some small rounding error. It is 120 orders of magnitude. That's a 1 followed by 120 zeros. It is widely considered the worst prediction in the history of physics when compared to actual observation. If the cosmological constant were even slightly larger than the nearly zero value we measure, the universe would have expanded so violently after the Big Bang that matter could never have clumped together. There'd be no galaxies, no stars, no Earth, and no you.
Section 2. Penrose and extreme entropy. Now that we've looked at the subatomic and structural forces, we need to transition to the macrocosm to discuss an even more severe instance of fine-tuning. And this one is directly related to the very first moments of the Big Bang. You see, the second law of thermodynamics states that entropy, or disorder, constantly tends to increase. Think of a perfectly wound-up grandfather clock. For it to tick forward and slowly wind down into disorder, it has to start in a highly ordered, tightly wound state. Well, for our universe to exist as it does, it was required to begin in a state of extraordinarily low entropy. Without this extremely low entropy initial state, there would be no thermodynamic arrow of time. Past and future would be basically indistinguishable. Furthermore, highly ordered complex structures, like the human brains we're using to think about this right now, simply could not exist in a universe that started as a messy, high-entropy soup.
Oxford mathematician and physicist Roger Penrose actually calculated the probability of this highly ordered, low-entropy initial state occurring randomly. The number he arrived at is 1 in 10 to the power of 10 to the power of 123. Just let the dizzying impossibility of that double exponent sink in for a second. It's a number so astronomically massive that you literally couldn't write it out in standard notation, even if you used the entire visible universe as a piece of paper and wrote a 0 on every single proton. The initial state of our universe wasn't just a random roll of the cosmic dice. It was constrained to an unimaginably specific value, and modern physics still struggles to explain why.
Section 3. 3 responses to fine-tuning. Now, what's really interesting about this slide is seeing how the scientific community interprets these mind-bending numbers. There's an active 3-way debate, and we're going to look at each one impartially. The first is the design hypothesis. This suggests the physical constants were intentionally set by an intelligence or a cosmic blueprint external to the universe. This view is championed by figures like physicist Paul Davies. However, many scientists raise a major philosophical and methodological objection to this. They argue that it simply displaces the mystery. Instead of explaining the improbable physics, it pushes the massive improbability onto an unexplained, highly complex designer. Essentially, you're trying to solve the mystery of the universe by introducing an even bigger mystery.
The second response is the multiverse hypothesis. In this view, our universe is just one of an infinite, or enormous, ensemble of varying universes. Naturally, we find ourselves in the one that permits our existence, right? Because we couldn't exist to observe the sterile ones. String theory's landscape, for instance, permits roughly 10 to the power of 500 different vacuum states, effectively giving us 10 to the power of 500 different universes, each with wildly different physics. But the main critique from physicists here is falsifiability. Critics argue that a theory which predicts literally every possible outcome actually predicts nothing at all, stepping outside the bounds of testable, empirical science and into the realm of metaphysical speculation.
The third is the necessity hypothesis. This argues that the constants aren't a matter of chance, nor are they designed, they are mathematically necessary. The idea is that someday, a future unified theory of physics will prove that these numbers couldn't possibly be anything else without breaking the fundamental laws of logic. It's an elegant, parsimonious answer, but it comes with a massive, almost wishful thinking caveat. This ultimate theory of everything proving such inevitability does not currently exist. So for now, it remains a brilliant, hopeful aspiration rather than a workable model.
Section 4. The Anthropic Firing Squad. To understand the multiverse response a bit better, we need to shift into the philosophical realm and critically examine the anthropic principle, specifically dealing with observer selection effects. Physicists analytically divide this into 2 camps. The weak anthropic principle essentially says it's unsurprising that we observe a life-permitting universe, because if it didn't permit life, we simply wouldn't be here to observe it. It's logically airtight, sure, but somewhat trivial. The strong anthropic principle, on the other hand, makes a radical claim. The universe must have properties that allow life to develop within it at some stage. To show why the weak principle might not actually solve our deep mystery, philosopher Nick Bostrom proposed a brilliant, clarifying analogy.
Imagine you're tied to a post, about to be executed by a firing squad of 10 expert marksmen. The order is given, they all fire, and they all miss. You're alive. The weak anthropic argument would say, well, you shouldn't be surprised that you observed them all missing, because if they had hit you, you wouldn't be here to be surprised. But that completely misses the point, doesn't it? As Bostrom's firing squad analogy clarifies, just because your survival is a prerequisite for your observation, that doesn't explain the mechanism behind why you survived. Why did 10 expert marksmen miss? The anthropic selection effect perfectly explains why observers only observe a life-permitting universe, but it doesn't do a single thing to explain why a life-permitting universe exists in the first place.
Section 5. Why does anything exist? Let's move to and see how this builds into an even deeper layer of reality. Philosopher Derek Parfit looked at these physics problems and realized they escalate into the ultimate existential mystery. Parfit asked the absolute biggest question: why is there something rather than nothing? He laid out 3 fundamental realities that a cosmic selector chose this reality. That maps to necessity, or 3, all possible realities exist, which maps to the multiverse.
Parfit demonstrated that the fine-tuning of the constants is just a highly specific mathematical manifestation of this broader metaphysical question. Whether you're looking through an observatory telescope or sitting in a philosophy class, we're ultimately trying to figure out why this exact reality exists instead of a void.
And this brings us to the most radical hypothesis yet. Legendary physicist John Wheeler proposed the participatory anthropic principle. He suggested that observers and the universe are mutually constitutive. Think of it like an inescapable loop. The universe creates the conditions for the observer, and the observer's act of measurement mathematically locks the universe into a definite reality. This means that consciousness isn't just some accidental byproduct of a universe that already existed independently for billions of years. Instead, consciousness and the physical universe are so deeply intertwined that neither can actually exist without the other. The universe is structured to allow consciousness because observers are fundamentally required to bring the universe out of quantum uncertainty and into reality. It is a stunning, paradigm-shifting idea that completely blurs the line between physics and mind.
Bringing our exhaustive deep dive full circle back to Fred Hoyle, the physicist who predicted the carbon resonance simply because he knew he was alive to ask the question. Hoyle lived with a lifelong disquiet about what he found, and truthfully, whether you lean toward a cosmic designer, an infinite multiverse, or elegant mathematical necessity, the honest response is to let the 120 order of magnitude anomalies bother you. We shouldn't rush to the certainty of a materialist dismissing it as a triviality, nor rush to the certainty of reading a specific designer into every decimal point. We need to hold it as a genuine, beautiful, open question. It requires profound intellectual humility to embrace this tension.
You exist right now because of a hyperspecific suppression of vacuum energy, an incredibly low starting entropy, and perfectly balanced fundamental forces that no one on Earth has completely explained. Stare into that vast cosmic dark and consider your own deeply improbable existence. For what, and by whom or by what, is the universe fine-tuned? That is a question that will keep scientists and philosophers searching for generations to come. Thanks for joining me on this explainer, and keep wondering.